Okay, greetings, guys. This is just page 3 of that review. In a bag of 12 purple and 5 pink coins, a pink coin is drawn and not replaced. Then a purple coin is drawn. Calculate the probability of this happening. Well, if you draw a pink coin, the probability of a pink coin, there's 12 plus 5. That means there's 17 coins total, and there's 5 out of 17 pink coins. But then you don't put it back. So there's now only 16 coins in. And out of those 16, a purple coin is drawn. Well, all 12 purple are still there. When you're doing the probability of one thing and another, you're going to multiply these things. So I have 5 out of 17 times 12 out of 16. I've got 5 out of 17 times 12 out of 16. That gives me 15 out of 68. Or if I change this to a percentage, 0.2205, so 22.1%. Are these independent or dependent? These are dependent because this first thing changed this. It changed it from 17 to 16 total. Also, think about it. If this first coin would have been purple, for example, there would have been less purple. Anytime this number changes from here to here, you know they're dependent. Okay, use the data in this table to decide which hospital to rather go to. Justify your answer with 2 of your own probability statements with numbers that proves your opinion is correct. Explain your reasoning. Well, I want to go to the hospital that I'm not likely to die in. So if I look at A, 63 out of 21, or let's look at this, 37 out of 2100, they survived. So 37 out of 2100. Well, what is that? Well, that's out of A, so that's a given A, the probability that you survive. The probability to survive given A is 37 out of 2100. That's 97%. So 97% of people that go there survive. What about out of B? What about the probability that I survive given I go to hospital B? Well, out of the B people, 784 out of 800 survive. Well, what is that? 784 divided by 800, 98%. Well, I'm going to go to B. I'm going to go to B because a greater percent of people survive at hospital B. That's where I'm going to go. I'm going to go where I'm more likely to survive. I don't know what's happening at hospital A, but hospital B, less people are dying. Well, a lower percentage. Now, 13 and 14, we switch gears and deal with some interest stuff. Now, remember, we didn't deal with this formula very much, but we dealt a lot with these. This was the formula for interest compounded n times per year, like every month or every day or every week. This was compounding continuously. So, and on these, the P was the principal, that's your starting amount in all of these. R was the interest rate, expressed as a decimal, and T was the time in years. N is unique to this formula, it's the number of compoundings. So John put $5,000 into a special savings account. So right now I know that's my principal. With a 6.5% interest rate, that tells me that the rate is 0.065. Remember, to change a decimal to a percent, or a percent to a decimal, you just take that and you move it back 2 spots, which means you may have to add a 0 here. Compounding continuously. That means I'm using this formula, e to the RT. So there's a lot of thinking that's going on right now as I'm reading this. Create an equation to represent the amount in the savings account. So I'm going to be using that equation because it's compounding continuously, where I have an amount equals the principal, which is the 5,000, times E, which is a number on my calculator. It's this number right above this LN button. It's right there. To the power of R, so 0.065 times T. Okay, now this says how much money will be in his account after 10 years. Well, 10 years, that means that's a time. Okay, so if I go 5,000 times E to the 0.065 times 10, okay, so now I type it into my calculator. 5,000, shift that button. That gives me the E to the 0.065 times 10 equals 9577.704. Now I'm only going to go 2 decimals since this is money. So 9577.704. That's going to round to 70. So how much money is going to be in his account? That much. But this says C. Look at the original problem. Does the answer to part B make sense? Why or why not? I would say yep. Interest over 10 years should be a lot. Meaning he went from 5,000 to 9,500. He made like $4,500 for just letting it sit there for 10 years. Cool. Okay. 14. Charlotte initially bought a phone for $1,000. Okay, I think that's going to be my principal. The phone will decrease 16.5% value every year. So that's a rate. So R is equal to 0.165. Create an equation to represent the value of Charlotte's phone. Well, it's not continuously because it's just said in value every year. So the amount of money it's worth is going to be $5,000 or $1,000 times 1 plus, but which of these am I going to use? Well, check this out. It actually really doesn't matter. If I take this interest rate, which is 0.165, how often does it decrease that much? Every year. How often every year? Just once. So it would be over 1. Well, isn't R over 1 just the R right there? So I could use either one. I'm going to use this one. I'll never use this one really. Okay? If it happens once a year, I'm going to use this one and I'll put a 1 for the end. To the power of 1 times T. Okay, so there's an equation. How much money will be worth in 2 years? So I got A equals 1,000 times 1 plus 0.165 over 1 to the power of 1 times 2, because it wants to know 2 years. Now, those ones aren't really doing anything, so I'm not actually going to type them in. I'm just going to go 1,000 times 1 plus 0.165 divided by 1, it's going to be the same thing, to the power of 1 times 2, which is just 2. And I get that number, 1357.225, so 1357.23. Whoa! Except that can't be right. It's worth more. So what's wrong with my model? My model is this is adding value every year. It's being worth less. So I need to decrease, and I do that by subtracting. Always think about an answer. Does it make sense? That's what this is helping you with. If I wrote down this 1,300 and then I said, does it make sense? I said, yeah, because it's going to grow. Wait a second. It's going down. How come it's worth more? So I can change that. So if I just go ahead and change that plus to a minus, there we go, 697.225. So 697.225, which is going to be 23. And I say, yep, it's lost value. Whole bunch of value. Okay, guys, that's it. Page 3. Good luck.